You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello everyone, thanks for being here today. I am Kirk Mona, and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Hey everybody, welcome to the show. I tell you, it was about 20 years ago that we're going back here for today's story. I was teaching a cryptozoology camp, and
Of course you were.
It was a ton of fun. If you don't know what cryptozoology is, this is like the study of unexplainably hidden animals, things like Bigfoot, the Loch Ness Monster, all the classics. But we also talked about like animals that really have been found and verified. So I was basically using, these, I don't want to offend certain listeners, but maybe say imaginary or undiscovered, perhaps, if I'm being generous, creatures, to really look at how scientists actually do verify the existence of a species. And so the kids were learning about science, about scientific skepticism, and frankly, we're having just a ton of fun. So I did, at the time, a bit of like a deep dive into the cryptozoology world. And I think part of the appeal is this idea that there may be mysteries out there yet to be discovered, right? It sort of harkens back to an age where explorers would set out on a journey and come back with these amazing discoveries. And there's something really romantic about that. And I will say it is easy to be jaded and frame it all as like imperialism and how those people were mostly just discovering animals that already were known to local people and lived in the area. And that's all true. But if we look at it for just what it was people excited for things that were new to them and to their friends and colleagues. And I think we can all understand that feeling of discovering something new and wanting to share it with people and how exciting that can be, whether it's like a new TV show or a restaurant. Like a restaurant can exist for like 40 years, right? But when you first discover how awesome it is and like, and you learn about it, that discovery is exciting for you, right? Even though other people have already heard about it. It doesn't really diminish that someone else already knew about it. It's still exciting for you.
Kirk, have you heard about this amazing restaurant? It's called the Cheesecake Factory. I'm just kidding.
Yeah, been there. Doesn't really do much for me, but I'm not a big cheesecake fan. That's fine. No, my parents were amazed to discover the Cheesecake Factory. I
think I've been to the Cheesecake Factory once in my life. I have nothing against it. I just haven't been there a lot.
I've only been to Cheesecake Factory once, and it's like, why? Go to somewhere more fun.
Good Lord, how is this turning into the Cheesecake Factory podcast?
Sorry, I totally derailed your topic. Let's go back to
quite a tangent. That's okay. Yeah, well, discovering something new, whether it's the Cheesecake Factory or whether it be an animal or a plant or just a new fact about a species that you maybe heard on this podcast, that can be exciting, right? So about 20 years ago, I got excited about the possibility of a new discovery. There was evidence, but it was also mysterious, strange, and hard to interpret. And so for this week's story, we're going to Rachel's realm, the ocean.
I love the ocean.
Now, I know you do. The ocean is full of mystery. Partially because it's so huge and so much of it lacks light, right? It's simply hard for us to explore. Yes. It's hard to get down into the deep parts as well. All that dark, cold water likely hides many secrets to this day. But after the end of World War II, the ocean's ability to hide things made the U.S. military very, very nervous because we had learned that submarines are a thing that can hide in the ocean, and the military did not like that. So the U.S. military developed a system of classified underwater hydrophones, which is the underwater version of a microphone. And it was called the SOSUS system, which stood for a sound surveillance system. I guess technically it's like ATM. You can't call it automated teller machine or ATM machine because it's in there, but it's just called SOSUS, okay? So its job was to listen for the sound of Soviet diesel and later nuclear-powered submarines under the water so we could figure out where they were going. This system was very successful and very secret, but operators also discovered something that they called the Jezebel monster. Ooh.
That's a terrible name.
This is because the name is very strange. It's actually because a very early test version of the SOSUS network was called Project Jezebel. And so that's probably where this name, the Jezebel monster, came from. Operators were hearing something that was definitely not a submarine, but they also had no idea what it was. I'm going to play you that sound right now. So here's an example of perhaps what they were hearing. I'll play this for you.
Huh.
Pretty weird sound. Do you guys have any guesses what that might be? What was the Jezebel monster?
A giant ocean frog.
Giant ocean frog. Good guess. This is actually the sound of the fin whale. So we think
very close to my guess, in fact.
Very close. The Jezebel monster was probably a combination of a number of things, mostly whale sounds. So like fin whales, great blue whales, humpback whales, things like that. We didn't really know what a lot of these things sounded like. Like no one knew what a blue whale really sounded like. So they're hearing these strange sounds, and it took time to figure out what they were. So when the Cold War ended, scientists finally got access to use some of the capability of the SOSUS network for research. And now NOAA, has also started their own listening program to further some of that research that was started just listening for stuff in the briny deep. So when I came along looking for mysteries to share with my students 20 years ago, I came upon a few mysterious underwater recordings that NOAA had just released, and the most famous was called Bloop, but they gave them very fun names. There was also Julia, Train, Upsweep, Whistle, and the names kind of describe a bit of what they sounded like. Do you want to hear these mystery sounds?
Yes.
All right. So we're going to go with the big famous one first, Bloop. And I'm going to warn you, it doesn't sound like a lot, okay? But this is the sound of Bloop.
Okay.
So could you make that out?
Sounded like bloop.
Yeah, you hear this like sort of background, just general noise of what it sounds like when you put a hydrophone in the water. And then there's this bloop, pop kind of noise. Mm-hmm. And scientists were baffled, basically. There was kind of disagreement about what this could be. People weren't really sure. Here's another one that I think is pretty interesting. A lot of these are kind of similar to sort of these strange sounds, but there's one that I really like that is called Train. This was recorded on March 5th, 1997, and it sounds like a train whistle, basically. You ready for this one?
Huh.
Here we go.
It did sound like a train whistle.
Yeah.
Yeah, especially when it gives a sort of like doo 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 kind of thing.
Huh.
So very mysterious. And like what are these sounds? First of all, it's pretty important to realize a few things about these recordings. First of all, they are loud. These sounds, a number of them were picked up on multiple microphones in the ocean that were thousands of miles apart. So this is not some small little, local noise or some kid playing in the water. Like these things have to be loud to be picked up.
This is across
such
the
great
ocean.
Distances. And these sounds would have to be louder than any known animal on Earth or animal that was known at the time, right? And the second thing to note is that both of these sounds have been sped up 16 times faster than they actually were and pitch shifted.
Oh.
So, yeah. So the actual sounds are, in fact, much lower and much slower. And when this passed around on social media and things like that, people were like, oh my gosh, this one, there's something that sounds like a train whistle, or this little bloop. It's like, no, this was really low frequency.
Okay.
So these facts, the fact that it's slower and lower and super loud, doesn't necessarily preclude them being animals. And partially because it's partially because we don't know like all the sounds animals make in the ocean, and possibly the possibility of them being animals like was left open at the time they recorded. They're like, I don't know. There's a couple things they could be. Maybe it's an animal. I think maybe because there had been this experience with the program of like the Jezebel monster, right? Because of the Jezebel monster, there was sort of a history of like being fooled before and something turning out to be an animal. So people were kind of like, well, it could be an animal. So the question is, are these unidentified animals? And now, about 20 years later, no, likely not. Some of these sounds
are they...
Oh, some guesses?
Underwater volcanoes?
Ooh.
That's a great guess. Volcanoes do make a lot of really interesting sounds, and that was looked at, but none of these sounds quite match what we hear from volcanoes. So some of these have been triangulated because they were heard on at least 3 microphones, and the sounds were coming from near Antarctica, or sort of that part of the world, if that might give you any clues. Now, we've also observed similar sounds in the 25 years or so since these were recorded, and it's most likely that most of the mysterious sounds that were unidentified back in the 1990s were actually ice quakes.
There it is.
So...
Yes.
Yeah, what people were hearing were...
Plus penguins.
Yeah,
plus penguins. Were huge icebergs calving off of glaciers into the ocean, or even enormous icebergs running aground on shallow areas.
Yeah.
Or like, like let's say shoals and islands, stuff that are underground, and this huge icebergs would sort of just like running aground, and you speed it up and it sounds like whoop kind of noise. So that's super cool. And you can imagine that these enormous icebergs crashing into stuff make some extremely loud and pretty fascinating sounds. So much like when a strange new signal is discovered in space, like the pulsars I discussed a few months ago, I think there's this human impulse to wonder if the answers are aliens in the dark or monsters in the deep, because it's really fun to speculate. And, it could be, right? We have to chase down all the possibilities. But the true answer is often sometimes more fascinating and teaches us more about our home on Earth or our home in the universe. So bloop is probably no longer like a unexplained sound like it was back in the 90s when maybe some of our listeners had even heard about this famous sound bloop. But now we do think that it's probably, just large icebergs scraping on the ocean floor.
Cool.
So my sources this week were
amazing.
NOAA, Wikipedia, and DUSITS.org, which sounds weird, but it's an acronym. It's a pretty cool website. It stands for Discovery of Sounds in the Sea. It's a neat website to poke around if you're into what role sound plays in the ocean. So DOSITS.org. Check it out.
Cool. Thanks, Kirk.
Yeah, we're going to go to break,
Thank
and
you.
when we come back, it'll be Rachel.
All right, welcome back, everyone. So last time we were here, I talked about dragons, which I guess we're kind of old, but I want to talk about something that's even older than dragons.
Because they were only like 4 million. That's not that old in the history.
That's
of
not
things,
that
right?
old.
Yeah.
Yeah, this particular group of critters has been around for 400 million years.
Now we're talking.
Oh, that's pretty
Now we're
old.
talking old. I think what happened was I had been researching for this when I was researching for Komodo dragons, and my brain stuck on this number for Komodo dragons instead. Sometimes that happens.
Look, Rachel, only nerds like us are like $4 million or 4 million years.
That's
That's not actually,
That's not that old.
actually,
Barely
in the history
there.
of the Earth, that's not very old. I think you'll find if you look at the geologic history of the Earth, tis but a few seconds on the hand of the geologic clock, Rachel. Yeah, but that's because we're total dorks. So yeah, 4 million years is a long time. So is 400 million. We're good.
Yes, we're solid. So this group of creatures, I have to say, is in Australia, but it's also in Papua New Guinea. They're found in rainforests throughout like the southern hemisphere.
Oh, okay.
So they're not just Australia. There's somewhere about 230 species, and actually very exciting. Sir David Attenborough actually talked about these creatures a little bit on his Netflix show Our Planet, which if you haven't watched it is beautiful and made me cry.
To be fair, he's talked about a lot of animals.
He absolutely has.
I was gonna say he has.
He has. So this particular critter, the koala, this particular creature is often mistaken for a lot of other things. People think of it as a slug, or they think it's a worm, or they think it's a caterpillar. It's none of those things.
What is
not
it,
a slug,
Rachel?
not a
What
worm,
is
not a
it?
caterpillar.
Yeah,
So it's long and cylindrical and slimy.
No legs, probably.
Looks slimy. It does have legs, actually. So the common name is the velvet worm.
Oh.
Okay.
I've heard of that, but I don't remember what it is.
So the family name, get ready.
I'm ready.
Onychophora.
I'm ready.
Onychophora, which means claw bearer in Greek.
Huh. Okay.
So it's not Latin.
That's pretty
it's Greek.
good, Rachel. Actually, that was quite creditable effort in the Latin there.
It was Greek
our
this
Latin
time.
expert has given you, or Greek expert has given her blessing.
I feel really good about this. It only took me 104 episodes. Goodness.
Perfect.
So there's
animals, someone disagreeing vehemently right now, like in the comments.
Absolutely. So these creatures are long, cylindrical, worm-like body plan, but they have a lot of legs. They have anywhere from 13 to 43 pairs of legs.
That's
and
quite
they have
a span.
These long, wiggly antennae.
That's a lot of legs.
That are actually that are on their head, and then they also have a pair of modified legs that are called oral tubes.
Oral tubes? That is that's quite a name.
Which isn't great. Don't really like that name very much.
No.
But unlike their appearance, which everybody seems to think that they look or could be slimy, they're not really that slimy. They do have a risk of being able to be dehydrated, but their name, the velvet worm name, comes from because they look super soft and velvety, and that is because they're actually covered in tiny, very delicate rows of scales. So these are arthropods.
Okay.
They don't have a exoskeleton like most arthropods and insects that we think of. These animals actually have scales that are very delicate and are either hydrophobic or they're just water resistant. And they can be super colorful with all kinds of different patterns and shapes, from orange, brown, red, blue. Some of them have stripes, including like chevron, which is crazy.
Cool.
And they're actually highly social creatures too.
Oh, really?
For a rather simple species, they actually are able to establish a pecking order and have a dominant female to whoever gets first dibs on whatever they are catching. And they can live and hunt in groups of like up to 15, which is pretty crazy. So they're small, but they have pretty complex brains for their particular size, especially.
Huh.
How small are they?
So anywhere from like 5 millimeters to 20 centimeters. So anywhere from like less than an inch, about a quarter of an inch, to 8 inches.
That's quite a span.
So average is about 2 inches.
Okay. Love that.
They're really cool. They generally make their life underneath the leaf litter of the rainforest. They're looking for they are predators. They are the ones who are actively hunting and are, they just look for like wood lice and things like that. So just little tiny critters that they can catch.
That's cool. I was thinking when you said they lived under the leaf litter that they were going to be like detrivores who were, like maybe eating some of the dead plant matter and leaves and stuff. But they're going after the little.
They are hunting. They are predators, and So here's the thing: they already are kind of crazy. So how they hunt? So they are able to use those antenna to like find a prey animal because they just have simple eyes, so they don't have really great eyesight or anything. So once they find a prey animal, what they will do is they're able to well, what
do they do, Rachel?
They're
what do they do?
They're able to spray out milky white slime, kind of like a goo, and
okay, it
quite literally will it can harden around them and trap the prey. It's
cool.
It's really cool. We're able to use this goo not only to have prey to catch prey, but also in self-defense. But it's so sticky that they actually can't escape, and it actually hardens up as they are going, so the prey can't escape. So then what will happen is
it's like a very quick epoxy.
Yeah. What will happen is the what they'll do is they'll take a bite, and then they will give some digestive saliva from their mouth into their prey and dissolve them. So they just create a nice smoothie. Yeah.
See, that's not nice.
No. But they have to eat.
Not that most ways you eat an animal is nice. I mean, but just taking a bite and being like, I'll come back later once you have been digested outside my body and slurp you up. That just seems, I don't know, a little rude.
Yeah. So it's just for, easier snacking. So they'll actually often will eat any excess slime as well in order for them to shore up their reserves, because it takes a lot to actually make this particular slime, and we're still learning what exactly
I'm sure it's very complex, complex molecules and stuff, probably hard to make.
Oh yeah. Also, you remember when I mentioned that they have 13 or to 43 pairs of feet?
Yeah.
And you remember that they're arthropods, right?
Yeah.
Yeah, their feet are fluid filled and hollow, and they don't have joints.
Oh, hydraulic feet.
Yep.
Cool.
And
that's rad.
The end of each little stubby little foot, each little foot has a little chitin? Chitin? No, chitin.
Chitin,
yeah. Hooked claw made out of chitin, which is why they're called
really hoping
claw bearers.
I really was hoping it'd be suction cups, so as they walk to it.
That would be really fun. I would have loved that.
That would be so cute.
That would have been really cute. No, they're claw bearers. Another thing that's actually really strange, especially among an arthropod, is a lot of the species of velvet worms. There's a lot of different ways that they're able to reproduce, and they have a variety of ways that they do reproduce. But a pretty good amount of velvet worms, I don't have the exact number, actually give birth to live young, which is weird in an arthropod.
That is weird.
That doesn't happen much.
Yeah.
Most of the time, an arthropod will lay an egg that has been fertilized and leave it alone. That's all. Nope. These ones, a lot of them give birth to live young, which is pretty crazy for a little arthropod. There's also some other ways that they reproduce of other species. Some of them are use parthenogenesis, which we've talked about before on this show. Some males will give a little sperm sac to a female. Some of them, the males can spike into a female to transfer sperm.
Yikes.
Yeah. But that doesn't seem to be as common, which is pretty crazy. Yeah, but these have been on my list for a while, and I really they're just wild creatures. What got me really was the slime. The slime really got me, and someone
got the animals that they're eating too.
Yeah, that's true. Some of them, some articles that I was reading, they called it like silly string. Apparently, looks a lot like silly string when it comes out.
Awesome.
Oh my
so
gosh.
that's particularly interesting. But there's a lot of really cool little velvet worms, and just watch out for them. Most of the time we should be fine. Like, they obviously like things like woodlice and millipedes and worms and things, so we don't have to worry about it. But they're really cool and now we know more. So that's what I have for you all today.
Awesome. Thank you.
Yeah, no problem. We're going to take a short break, and when we return, it'll be Victoria.
Hey, we're back. So you two remember when I nearly severed the tip of my little finger back in September?
Yes.
How could we forget?
Of course you do. I did an episode later about human fingertip regeneration. It is, by the way, almost back to normal at this point. So a little
nice
funny sensation at the tip, but we're getting close.
Oh, well, that's good.
I'm actually not going to revisit that topic, but I do bring up my injury because one of the things that happened when I was at the urgent care getting my finger taken care of was that the nurse confirmed that I was up to date on my tetanus shot.
Oh, good.
That's always good.
And yeah, if you've ever gotten any kind of serious wound, particularly a puncture wound or one that might have been contaminated
Mm-hmm.
by soil, you would have been asked this question too. And if you couldn't remember, or if it had been more than 10 years since your last shot, you would have been given a booster. As it happened, I was up to date.
I am 5 years overdue.
Kirk, you work outside.
Should get on that.
I know exactly when I had my last shot, because when I was building, moving a wall in our old house.
Oh no!
For the soon to be arriving child that I have,
your child is in high school.
Yeah, I know. I put a framing nail through my ankle.
No!
And so I got a shot at that time, and the doctor was like, well, here's a good thing. Every time your kid turns 10, 20, 30, 40, it's time to get your shot.
And then you didn't do it.
I haven't done it, but I do.
It worked for none of that.
At this rate, I should wait 5 more years, and then I'll be on target. But I've been feeling after you do your topic, maybe I won't want to wait. Yeah, let's hear what Victoria has to say.
Well, what is tetanus anyway, and why do you need a shot for it? Unlike, say, measles or polio or influenza, you never hear about tetanus epidemics breaking out somewhere on the globe.
Right.
I guess.
So what are we being protected from? Tetanus is caused by a nasty little bacterium called Clostridium tetani. I stuttered there. It's just tetani. It's not tetani. And as you might suppose, from what I was talking about earlier, it's introduced in the body through a break in the skin. Now, the typical thing you hear about is like a rusty nail.
Right.
And this makes a lot of people think that there is something about the rust that causes tetanus. That is not the case. It's really just because a rusty nail is likely to be a dirty nail.
Okay.
And the bacterium Clostridium tetani is actually a very common organism in the soil and in animals' intestines. So it's around. And it actually doesn't typically cause any problems inside the digestive system of an animal. But if it gets into your skin, it can be a big problem. It's what is called an obligate anaerobe. And that means it can only grow where there's no oxygen.
Okay.
So,
Okay.
say you have a puncture wound. You have a puncture wound and some of the tissue around that wound dies. So the bacterium got in to the wound, and then it's just cut off from blood flow and it's cut off from the air. That's a great place for this bacteria to grow.
Gotcha.
Love that.
And to multiply. Yeah. But it's actually not the bacteria themselves exactly that cause problems. It is the toxins that they make.
There it is.
There are
So
a few of
very
them.
common, yeah.
Yes. Yeah. One of them is called tetanospasmin. It's a
Doesn't
very
sound
potent
good.
toxin, the lethal dose. Yeah. You might, I mean, you probably already know about what tetanus is, but you might kind of hear from the name where we're going with this. But the lethal dose is 2.5 nanograms per kilogram of body weight.
Oh.
So, yeah, like for a typical adult, I calculate that as about 2/10,000th of a milligram.
That's
Hey, Kirk, want to go get tetanus
that's concerning.
boosters?
Yeah, it's been. You guys enjoy the rest of the show. I'm gonna run down the road, get my booster. Go on.
Yeah, so this toxin goes into the lymphatic system and the bloodstream, and it spreads around the body. The real issue starts when it then crosses into the nervous system, and it acts there to block some neurotransmitters. Now, neurotransmitters are these chemicals that carry signals between nerve cells and also between nerve cells and muscle cells and other cells of the body. And there are neurotransmitters that tell cells to do stuff, and there are neurotransmitters that tell cells not to do stuff.
Right.
Gotcha. Yep.
Those are called inhibitory neurotransmitters. So it blocks some of the inhibitory neurotransmitters that basically keep your muscles from firing all the time. So
okay.
you start getting muscle spasms.
Yep, I was about to
Yeah.
say,
And
there's
it
the
usually
name.
starts, yep. Usually starts in the jaw, which is why another name for tetanus is lockjaw.
Right.
Of course.
Very vivid imagery there.
Oh, no.
These spasms can become so severe that the entire body forms a rigid backward arch. There's actually, if you go to the Wikipedia page for tetanus, there's this famous, horrifying painting of this.
You could also
painted in 1809 by.
It'll also be on our Instagram. Awful.
I'm gonna
Yep.
look.
There was a surgeon and artist named Charles Bell who painted this painting.
Oh, that's not great. So the person is like heels on the ground, elbows on the ground, doing a big like complete rainbow arch.
Oh no.
That's no thank you.
Yeah. These spasms can be so severe they even break bones. And this is in addition to fever, sweating, headache, trouble swallowing, and other unpleasant symptoms. The death rate is around 10%. Even today, if you don't get the vaccine and you get this,
That's not great.
And there are about 60,000 deaths worldwide currently. Only 30 in the U.S. because the vaccination uptake is pretty high here for tetanus. But that is down significantly from what it used to be, the 60,000 deaths. You go back 30 years and it was a few 100,000.
Oh, gosh. Yay, vaccines.
I was actually... Yay, vaccines.
Yeah.
I was actually originally going to talk about the whole genus Clostridium as one big nasty family, since the other Clostridium species include Clostridium botulinum, which causes botulism poisoning, and Clostridium perfringens, which causes gas gangrene, food poisoning, and a number of other problems.
Whoa.
Wonderful.
Well, and the thing they have in common is that they're all obligate anaerobes. They can only survive without oxygen. And that's one reason why botulism is such a problem in improperly sterilized canned goods. Because a can is obviously sealed off from the air.
So it's perfect growing conditions.
They form, yes. But also these species all form spores, which is a very hardy survival form of the bacteria, which means they can often survive really extreme conditions like drying out or freezing or boiling, which is why if you're canning foods that are not acidic enough and you just can them in boiling water instead of a pressure canner, then you can get botulism issues.
Lovely.
Okay.
There's also something that used to be called Clostridium difficile, which is actually it's now called Clostridioides difficile, which is the cause of really nasty and persistent diarrhea infections, which are often a problem following a course of antibiotics. If you've heard of C. diff,
I've heard of that.
It's a big,
absolutely.
That's what it is. So it used to be in the Clostridium genus, but it was moved recently to a different genus. And this gets to the problem, which is that even more than for animals or plants or other groups that we study, the clades that bacteria have been placed in until recently, they're turning out to be, pretty meaningless from a genetic standpoint.
Right.
You know, for most of the history of studying bacteria, scientists classified bacteria by, their shape, their size, how they grow, how they react to certain stains, what they can eat or what they can not eat, what they can tolerate or not tolerate.
Yep.
Stuff like that.
Been a productive
Sometimes those
100
features
years.
do mean that they're related. Yeah. But, we are discovering by DNA analysis that sometimes these groups are really, have very little in common in a lot of cases. And Clostridium seems to be one of those categories. There were a couple papers that I briefly dipped into that were like way over my head, but they were going deep in the weeds on like the phylogenetic trees of this genus, and it was a mess.
Okay.
So it's just like it's an interesting reflection on, as we learn more about the DNA and the molecular levels of bacteria, we are learning just how much we really don't know.
Oh, yeah,
Sure.
absolutely.
And those, and as we like to say on this show, nature likes to laugh at the little boxes that we put
100%.
things into.
It does.
What are
Well,
categories?
it's interesting that the whole idea of pairing things together that sort of look alike or look alike and have similar behaviors and all these similar adaptations and whatnot worked really, really well for the most part for, plants and animals.
Yeah.
And I often teach about insects. How we have
macrofauna.
kids looking at insects and be like, put these into groups. Well, these all look like grasshoppers, and these all look like beetles, and these all look like bees, and these all look like flies. And it's like, it turns out that's what people did 100 years ago, and it still works today for the most part. Like, it just looking at them tells you that. But for bacteria, I guess not so much.
Yeah. Yeah. Exactly.
Tried and true didn't work.
Yep. So don't get tetanus. Get your booster. And bacteria are mysterious.
Oh, 100%. We'll definitely talk about them more.
200%. Oh yeah, I've got a few
That is what I have for you this
interesting
week.
bacteria on my list.
Ooh.
Oh, well, thanks everybody.
Yeah, thanks, Victoria. All right. See you all next week.
All right.
Bye.
Yep, bye-bye.
See you then. Bye.
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange.
Hey friends, this podcast is powered by Podbean Podcast Hosting. Are you thinking about starting your own podcast? Or maybe looking for the best home for your podcast? Check out all the amazing features Podbean offers with unlimited bandwidth and storage for an affordable price. That's right, unlimited. Visit podbean.com/strange to check it out today and get a month free. It's podbean.com/strange.